Okay, so 7-1 was just Pythagorean theorem. A squared plus b squared equals c squared. So as long as it was a right triangle, we could use it to find unknown sides. So today is the converse, which means if we can show that the Pythagorean theorem works, then we know that it's a right triangle. So it's the exact opposite of what we talked about last time. So taking that even a step further, this technically is the converse. It says if the Pythagorean theorem works, when you square the two legs and add them together, it's the same as squaring the c side. So if this works, then we can verify that that's a 90-degree angle and ABC is a right triangle. This is the exact opposite of what we did last time. We're taking that a step further with these two ideas here. So I try to simplify this as much as I can for you. So if it's not equals, it's either less than or greater than. That's the only real three options that we have. So first thing I want you guys to see is how I label these triangles. Back to my original here, we have A, B, and C. Notice this is capital, capital, and capital because we know that vertices have to be capital letters. That goes back to chapter 1. So directly across from my vertex of A is called my A side, lowercase a. That's the name of a line, again, going back to chapter 1. Directly across from my vertex C is my line C, again, lowercase. Directly across from my vertex B, of course, is my side B, or my line B, and those are lowercase. Same idea applies to these two. So my triangle is named ABC, but look, across from A is lowercase a, or side A, across from B, across from C. You guys see how that's set up? And we know by now that capital letters and lowercase letters are important. So looking at how this is set up, we're saying that C squared is less than A squared plus B squared. So if that's the case, then that means that angle C, so if this side is less than these two, then that means this one is acute. Angle C is smaller than 90 degrees. That means it's acute, which means if C is too small, the entire triangle is acute. So this is how I remember it. This, I think, is the easiest way to remember it. Plug in the A, the B, and the C. Remember, C is always your biggest one, whether it be a right triangle or not. You're going to plug in C as your biggest number and see which of these scenarios works. So if C is too small, meaning C is smaller than A squared plus B squared, then that means that it's acute. If C side is too big, meaning if C squared is greater than A squared plus B squared, then that means that my C angle is bigger than 90, which means the entire triangle is obtuse. Okay, do you guys kind of see the relationship here? This is how I remember it. If C is too big, then it's obtuse. If C is too small, then it's acute. If C is equal to, then it's right. If these are confusing, then remember it the way it's written formally. Let's look at some examples. First one says, decide if the numbers can form a triangle. What are they talking about there? We learned that last block, right? How do we know if three numbers form a triangle? Who remembers?
You would add them together, and if they're over the other number, if they're greater than the other number, then they're...
Got it. So you have to add two sides, and if it's bigger than the third side, then that means it does form a triangle. When I add these two, is it bigger than 50? Yeah, I hope so. Add these two, is it bigger than 14? Add these two, is it bigger than 48? And like I've told you guys, you shouldn't have to actually add them. I know when I take 48 and I add 14 to it, it's definitely going to be more than 50. That's all I need to know. So I did verify that it can become a triangle, or it can make a triangle. Next thing I need to decide, is it right, acute, or obtuse? Now typically when they give you the three sides, typically the third one is your biggest one, but just make sure you put the biggest one as your C. So I'm going to plug it into my Pythagorean theorem. I don't like to put anything here. You can either put a box in here because we don't know what goes in there yet. You can even put a question mark in there. Just don't put anything in there yet because we don't know if it's an equals, a greater than, or a less than. Okay, who can help me out with 14 squared? Somebody have Desmos open for me, please. 14 squared.
96.
196. And I need 48 squared.
23.
Thank you. I don't know what goes in here. And 50 squared.
2500.
Thank you. What do I get when I add these two things together? This is kind of the important part. Anybody able to do that in your head?
$2,500.
So what scenario do I have? Is it equal to, less than, or greater than? I have to ask just to make sure we're on the same page. It's equal, right?
Maybe.
So because, don't stop here, because it's equal, we know that it is a right triangle. So this is the answer that I'm looking for. This is the work that backs up this answer. That one was hopefully an easy one. Let's look at the next one. Same scenario, we're gonna plug it in and see which of those scenarios that we just talked about works. So 20 squared plus 21 squared, we don't know what goes in here. Remember, the biggest number always goes on your C side. Who's gonna help me out with squaring? 20 squared?
400.
21 squared? Say it again.
441.
Thank you. And 28 squared?
784.
Thank you, I appreciate it. What do I get when I add these two? Anybody will do that in your head? I hope. Go ahead.
841.
So going back to your comparing number of days from years ago, we know that 841 is greater than 784. So remember where our C side is. Is our C side too big or too small? It's too small. So because my C side is too small, then the triangle is acute. And looking up here, the C side is smaller than the A squared plus B squared side. So this one is acute. I think looking at C side being too big or too small is the easiest way to look at that, because you could plug this in a couple of different ways. You could have your C side on this side, and I think sometimes that gets a little bit tricky, so just be aware of that. Okay, and our last one. This one's a little bit interesting. We didn't check this one to see if it was a triangle, but it does. So how do I verify if this is a triangle when I have square root of 8 in there? Kind of odd, isn't it? What I do is estimate it. You should be able to estimate that in your head. What do you think the square root of 8 is? It's a little smaller than the square root of 9. Square root of 9 is 3, so what do you think the square root of 8 is? Ballpark, wild guess. Joshua,
Like 2.8 or something.
that's not a bad guess. And all we really need is a kind of a ballpark to check. So when I add 2.8 and 6, is that going to be bigger than 4? 2.8 and 4, is that going to be bigger than 6? And 4 plus 6, is that going to be bigger than 2.8? Absolutely. So it does form a triangle. Now we need to decide if it's right, acute, or obtuse. I'll put this one over here. So we're going to plug in. Be careful how you deal with that square root. You're squaring the entire side, and this is the proper notation. What happens to this? When I square this, what do I get? We talked about this last time a little bit. Go ahead.
8.
You're right. Remember, when I square and square root, they cancel each other out. We talked about that last block. So when I square root and square, I get 8. Don't let that hurt your brains. That's a pretty simple idea. It's like adding 2 and then subtracting 2. You're going back to the beginning. 4 squared is 16. 6 squared is 36. What do I get when I add these two?
24. What, 24?
Yeah. So it shouldn't be a surprise. I'm giving you one of each example. 36 is bigger than 24, so because my C side is too big or bigger than my A and my B, this one is an obtuse triangle. You guys see the 3 different scenarios? C side's too big, it's obtuse. C side is too small, it's acute. Taking this a step further, do you guys have this so I can erase it? Let me explain why you guys are writing that down. So it says points A, B, and C form a triangle. They already tell me this first step that we did over here. It says, is this triangle right, acute, or obtuse? Well, remember, these are side lengths. It has a length of square root of 8, a length of 4, and a length of 6. But I don't know what my side lengths are, but I have points. Have we ever learned how to find the length of 2 points on the coordinate plane? Oh no, what did I teach you?
The distance
The distance formula. Imagine that, it's coming back again. Didn't I tell you?
The return.
You're gonna start rolling your eyes and saying, oh my gosh, we've learned this so many times. Yes, it's not going away. It's gonna keep coming back because it's so helpful. I wanna caution you, do not plot these on the coordinate plane, eyeball it and say, yep, it's a cube, because it looks like it. We have to show it using the distance formula, okay? So even though I think that could kind of tip you off and give you an idea, but that will not get you credit on any quiz or test, okay? Okay, so distance. Remember, our distance formula looks like this. Guys, remember that? Subtract your x's and square them, subtract your y's and square them, add them together and square root last. So I'm gonna do this kind of quickly so I don't make my video too long here. So it'll be from A to B. I have -8 minus -5 or +5. -4 minus -2, which is like +2. When I subtract this out, I get -3. -3 squared is 9. When I add this, I get -2. -2 squared is 4. And I get the square root of 13. I'm not going to go any further than this, guys. Don't do decimals. Don't do simplest radical form, and you'll understand why in a minute. So that's my AB. Let's do from B to C. So I'm using these two. I'm going to subtract my x's, square them, subtract my y's, square them, and then square root, add and square root. So my x is -5 plus 1, because you're subtracting. -2 plus 7 squared. This gives me -4. -4 squared is 16. This gives me 5. 5 squared is 25. And this gives me 41. And I have one more to do, so I did A to B, B to C. My last one's gonna be from A to C. And I want you guys to see how I'm labeling these. So if I ever had to go back and made a mistake or need to fix it, I can see exactly what I did. So from A to C, -8 minus 1 or plus 1 because it's minus a negative, and -4 minus -7, which is like -4 plus 7. I'm really squishing this in. -8 minus 1 gives me -7. -7 squared is 49. -4 plus 7 gives me 3. 3 squared gives me 9. When I add these together, I get 68. 58, thank you, that didn't look right. Okay, so here's my 3 sides. This one required a little bit of work. This is no different now than these are. So taking these 3 side lengths, I'm gonna plug it in to see if C is equal to, greater than, or less than. So I have 13 squared, square root of 13 squared, square root of 41 squared, and square root of 58 squared. Remember, the biggest side is my C side. This should be super easy. Because I didn't take this any further, there's nothing to undo. Square root of 13 squared is 13. Square root of 41 squared is 41. Square root of 58 squared is 58. When I add these two things together, I get 54. So C side is what, too big or too small? Too big. So this one is obtuse. Okay, I have homework posted over here. So in the past, my answer key shows graphing the points like this kind of problem. I don't need you to graph it. I'm more concerned with you doing the distance formula and coming up with right obtuse or acute. So when it says to graph it, you don't need to graph it. I just need you to use the distance formula and find that answer. Okay? So again, there's your work for today. Whew. Good, We're good.